What's going on, everyone? Welcome back to the channel and welcome back to another video. I don't know if I ever told you all, but I am incredibly lucky to be in a space where it's pretty much summer all the time. I mean, take a look at this, guys. I mean, look how gorgeous this is. So as you all can see, I'm in a very beautiful park. It's one of the benefits of being in Florida. More importantly, that is not why we're here in this video. This video today is going to be focused around managing and monitoring Linux processes. So let me take a second and let you guys know that before we start any video, I always say this: go ahead and check out the description. Make sure you guys are updated on everything that's going on with the channel, because I keep everything updated in the description. So in this particular video, of course, we're going to be learning on ideas and concepts that we've learned from in the past. So if this is your first time coming to the channel, go ahead and check out the description. And also, specifically what I'm referring to is the Linux playlist that's there. Get caught up with all the videos that we have there, and then when you are all caught up, you can come back to this video and learn from there. So now that you guys are all caught up with the channel and you've seen everything in the description, there's one more thing that I need from you all before we go ahead and move on with today's video, and that's to go ahead and give me a like for the channel, as it helps the channel grow. Make sure you hit the subscribe button and also turn on your notifications so that way you're notified whenever we upload new videos to the channel. And lastly, of course, share this video with a family member or friend. Now on to today's topic. We're going to be talking about managing Linux processes, and not only managing it but monitoring it as well. Those two work hand in hand whenever you are working with the operating system, and not just Linux in general. When you're working with Windows, it's the same concept too. The idea is that you want more resources going to the things that actually do the work than it is to run the operating system and everything else that goes along with it. Now, since this is going to be a little bit more of an in-depth video, we decided to break it up into 4 parts. So welcome back, guys, and welcome to the next video in our Linux journey, especially when we talk about managing and monitoring Linux processes. And this is part 4 of a 4-part series. And if you haven't seen any of the other 3 videos, I highly recommend that you go ahead and check them out. Links will be in the description and possibly somewhere up on the screen as well. But those 3 videos are going to be important because what we're going to learn about today builds on those 3 other videos. Now, I say this in every video: if this is the first time you guys are coming to this video, or you haven't watched the other 3 yet, make sure you check out the description and make sure you watch those videos, because we build on prior knowledge and I don't want you guys to get lost. So for part 4, this is going to be a little bit interesting. We're going to talk about the importance of working as a team together in order to accomplish a mission. And specifically, one of the things that I wanted to highlight is how a systems engineer and a software developer, or sometimes you can hear the words for system engineer as system admin, or SRE, site reliability engineer, how any of those guys or gals, how they work with software developers in order to be able to, again, complete a mission, or in our case, have an application running on a machine. And that's all computers are good for. All they're good for is for running workloads and helping us complete day-to-day tasks. And so it's important that people work together in order to make sure that we complete the mission. And so the interesting thing about this video as well is that not only will you see how these people work together, but it's going to tie in exactly what we learned in part 1, part 2, and part 3. All of that info is going to be tied together here. So you're going to see this real world example and how it applies. So if you guys haven't watched those videos, make sure you go ahead and check that out. So with housekeeping out of the way, guys, let's go ahead and jump into today's video. I'll see you guys on the other side. Welcome back, everyone, and welcome back to the desktop. And by now, this environment should be very familiar to you. If you don't know how to bring up a terminal, or you're unfamiliar of what this environment is, make sure you check out the description in the video, as it always has the latest and greatest information. Plus, what we also do is we put a link to our Linux playlist on there, so that way you can go check on some other videos and get all caught up And I say this in every video, our videos build on top of each other. So if this is the first time coming here, check out again some of those other videos, because we will be building on ideas and concepts that we've learned in the past. So it can be very easy to get lost. And of course, I don't want you to be lost. So with housekeeping out of the way, let's jump into today's topic. Now for this last part that I want to talk about, you certainly learned a lot when it comes to monitoring and managing Linux processes. So this is actually a special example that I made for you all that ties everything together, so that way you can see this happening in a real world example. And funny enough, now I'm going to actually show you how important it is for people to work together. And especially when you're in these big tech teams where you have developers and you have system admins, or sometimes they can be called system engineers, or sometimes I hear the term SRE, so site reliability engineer, right? All these different titles and all these different people have to work together to make sure that they're able to accomplish the mission. And in this example, we'll show you how important that is. So let's take a look at what I have for you guys here. So if we look at what I have in my home directory, the example that I want you guys to focus on is this directory over here called process example. So if I were to go inside process example, let's take a look at what we have. Here is a C code that I wrote for you, and it's very, very simple. It's a while loop. So let's take a look at what's inside of this C program. And so if I were to open up Vim, so here we have a basic C program, and I'm not going to get into the details of it because, again, this is not the particular medium for it. If you guys want me to do a programming channel, I will consider it. Leave me a comment in the comment section below. So the thing that I want you to take away as you're looking at this particular program is that all it is a program that says subscribe to Acosta E.T.F channel, and it tells you what its current value is. It prints an extra line and it increments that start value. And so what is the start value? The start value is 0 and the end value is 20. So if we look at how many times we're going to do this, it's a total of 20 times. And the reason why we know that, of course, is because your start value is 0 and your end value is 20 minus 1. 20 minus 1 is 19. So if we count from 0 to 19, of course, that's 20. So now let's go ahead and compile this particular program. So we do GCC, which is our compiler. We can do the while loop.c. We'll do -o in order to name our program. And we can call this while loop good. And if we do an ls, we can see that there is our while loop, and it's a good program. And the reason why I say it's a good program is because you'll see the difference between a good and a bad. So now, in order to see what we have going on here, let me make this a little bit smaller. Let me open up another window here. Let's make this a little bit bigger. All right, so that should be good. So let's go ahead and run the top command, and we talked a little bit about the top command before. And remember, the top command basically shows us in real time what processes are running. So one of the things that I want to do now is I want to run this while loop good program, and I want to see how much resources are being used by this particular program. And one of the things that I want to focus on specifically is the processor usage. And if you recall, based on what we previously learned, we use Shift and P in order to sort by processor usage. So let's go ahead and run this particular program. So if we were to do // and while loop good, we can see here that it was very hard for me to see the program run on top because this program ran immediately. In fact, actually, we see the output here. So we see here that the current value is 0 all the way until we finished that. The current value was 19. So it says subscribe to Acosta ETF. And I don't know why you guys haven't. So go ahead and subscribe to the channel. But you can see here that it ran 20 times. 0 all the way to 19 is 20. Now here's an interesting thing. Let's say if we take a look inside, I'm interested in this while loop, right? If I'm going to cp for copy while loop dot c, and let's call this while loop bad dot c. And you see here that we have a while loop underscore bad dot c. So let's open that up with gvim actually. Let's change the color here. Now guys, here is where, when I mentioned before that you have a team working together in order to solve a particular mission, this is a great example right here. On one hand, you have the system administrator, which is the person who's responsible for this environment that's running the application. They are the ones who are monitoring this environment using top, right? They're concerned with how much CPU is being used, how much memory is being used, and you want to make sure that there is availability or a large amount of resources in order to efficiently run all these applications. Because when you run out of resources, that means that application is going to be sluggish, it's going to perform very poorly, and that provides a poor user experience for the person who's using that application on the other side. So that's the admin side of things. Now, this side of the house where you see me bring up that while loop bad program, this is the developer now. A developer comes in and they're not necessarily looking at top, right? They're just saying, hey, I need to put in my code and make sure this application is built because management is beating me up over this particular program. And I want to show you guys how one little line of code can change the entire difference, meaning it can really negatively affect the particular machine. And it's going to be the job of the system administrator or the systems engineer, or sometimes I hear site reliability engineer, to monitor this environment and make sure it's providing a good experience for customers. If we look at this program now, and we say to ourselves, okay, cool, this program is going into a loop, and each time it goes into a loop, it basically compares the start value and it sees if this start value is less than or equal to the end value minus 1. Now, in order for this program to terminate at some time, you have to always increment that start value, because if you don't increment that start value, all you're doing is saying start value, which is at 0, is that less than or equal to end value, which is 20, minus 1, which is 19. So basically, is 0 less than or equal to 19? Okay, let's execute what's inside of that while loop. If you remove this start value plus plus, right? If I were to remove that by doing a comment, so by commenting it out, that essentially means that I remove that line. That start value will never increment, right? It will never go up to 1, to 2, to 3. It will always stay at 0 because we removed the start underscore value plus plus. So let's go ahead and write and quit. Let's go ahead and compile that program, gcc while loop bad.c. Let's do a -o. Let's call this while loop bad. And so there you see we have the bad program and we have the good program. Look at the difference now when we run the bad program. So here is what the bad program looks like. And by the way, I want you guys to pay close attention to the top command that I have here open for you, because your jobs as system administrators is to see this big problem that you're going to see. And by the way, before I do that, let's go ahead and open up another window. Let's keep this here. So let's run this program and see what we get. So as you see here, that bad program, because we removed that increment, meaning 0 gets incremented all the way up until the point it gets to 19, and it never gets there. So essentially what we programmed as a developer was an infinite loop. That infinite loop is chewing up our processor because it forever keeps going and going and going, and it doesn't stop, right? It's just an infinite loop. And because it's utilizing all of our resources, we can't give some of those resources to other applications. So what that means is that our other applications, or possibly even the operating system, could run sluggish and gives a poor user experience. So now it's up to the system administrator or the systems engineer, or sometimes I hear site reliability engineer. It's up to them now to see, oh man, we got a problem here. We got this program here called while loop bad. This program with a process ID of 41231, that is eating up our CPU, and it's almost at 50%. So we have to go now and actually terminate that process. So with what we learned before, we can go over to this terminal that I have here. Let's do a kill. And remember, this is the difference now between that kill-9 and kill-15 that I talked about earlier. We're going to do a kill-9 in this case, and the reason being is because this is a bad program developed by our developer, and we want to terminate this immediately. It wasn't a good program. If it was a good program, we would use the 15 in order to say, hey, terminate in a clean way. But because we wrote the code and we saw it was a bad code, we're going to use a kill-9 here. So let's go ahead and give it the process ID now. And let's go ahead and kill that. And you can see that the process was killed. The program is no longer running. It even tells us here that it was killed. And what you can see now is that our CPU went from being heavily used to now is back to its normal state, and we're able to service other applications that need the CPU, or it's able to service some other processes which will provide a better user experience for those utilizing the operating system, or possibly interacting with another application that runs on this particular machine. And that is a phenomenal example of how you can see how a developer along with a systems engineer work together to complete a mission. If one is not talking to the other, you're going to have problems like you see in here. And it also goes to show you how one little line of code from a developer can bring down a whole computer practically. So it's very important that the developer also takes pride in the work that they do. And then of course, as you've seen here, the systems engineers are also important, because sometimes these developers will go ahead and develop stuff, and not by malicious act, right? Sometimes they just don't know what is happening because they don't monitor computer resources as well as a systems engineer or a computer admin does. So welcome back, everyone. Great to see you back. And by the way, I'm pretty sure you all learned a lot when it comes to managing and monitoring Linux processes. Now, in every video I say this, if you didn't understand it, go ahead and rewatch the video again. Practice makes perfect. Remember, I didn't know this when I first started, and some of it was very, very confusing. So hopefully you guys rewatch the video if something wasn't clear. Also, leave me a comment in the comment section below and let me know if something wasn't unclear, or if you guys love the video. I mean, again, I feed off of your energy, and if I'm doing an awesome job, guys, let me know in the comments below. Now stay tuned to the channel as we're gonna upload more videos on engineering, tech, and finances. But more importantly, before you guys head out, I need you to do me a favor and go ahead and give me a like for the video, as it helps the channel grow. Make sure you guys go ahead and hit that subscribe button below. Also, make sure you ring the bell so that way you're notified whenever we upload new videos to the channel. Lastly, if my videos are helping you out and you really enjoy the content that I'm producing, make sure you go ahead and share it with a family member or friend so that way they can get into their tech journey, or they can probably learn a thing or two about money. So I'm going to continue working out here, guys, as far as going for my daily walk and run and enjoy this beautiful scenery that you see behind me. And you guys stay tuned to the channel. Go ahead and practice as well what you learned today. But most importantly, I will see you all in the next video.